Hello students. So now that we are aware of the practical number 1, which has this setup as we can see, and most of us have seen a lot of videos on the social media space about how the experiment is to be conducted. The question is, what are we going to be determining in this experiment? So here I have a title for us: determination of the spring constant of a spiral spring. So I believe in this experiment, what we are going to be determining is the spring constant of the spiral spring. Now, so if we are going to be determining the spring constant, what then will be plotted on the graph? So let's look at this. We know that this period of a spiral spring is given by T is equal to 2 pi square root of m over k. This is the period of spiral spring, although in most cases it's m naught over k, m plus m naught. The m naught stands for the mass of the spiral spring. That is, if we are using a spiral spring that is heavy itself, right? So, but this spiral spring has a very small mass, so we consider that the mass is not significant. So our formula for the period should be m over k. So what are we going to be plotting in this experiment? Let's look at this. If we should write this 2 pi square root of m all over square root of k, cross multiply, we should have t square root of k is equal to 2 pi square root of m. Divide both sides by t, we should have square root of k is equal to 2 pi square root of m all over t. Why am I doing this? Because I'm aware that this experiment will be asking us to plot a graph of the mass against the period. So I'm trying to see if we can get mass against period here. What we have here is period, but of course the experiment will be asking us to plot period square. So let's take square of both sides. If we should take square of both sides, we should have, therefore, square root here becomes just k, and then we have here becomes 4 pi square, right? Here also the square root goes, and then we have over t. We have 4 pi square, and then we have multiplied by m over t square. And we are aware that what we were given our masses, and we are conducting some oscillations, vibrations, and then we've obtained periods in this experiment, as what we are seeing with videos that are going around. So that means this experiment is either going to ask us to plot mass on the vertical axis against period square on the horizontal axis. So if that be the case, it means our experiment is going to be asking us to do this after plotting the graph s, the slope. If this is not the case, also it can be 4 pi square all over s. In this case, it means, therefore, that we are plotting a graph of t square over m. That is when it becomes inverse here. So this is most likely what we are going to be seeing in this experiment. Either we plot this where we are plotting m against t square, or this where we are plotting t square against m on the vertical axis, or on the horizontal axis. So if that be the case, it means, therefore, that at a point they will ask us to evaluate k equals to 4 pi square over s, or probably evaluate k equals 4 pi square s. These are the two cases. At the end of the experiment, if we are asked to do this evaluation, it means we are looking for the spring constant of the spiral spring. And if we are looking for the spring constant of the spiral spring, we all know from Hooke's law that spring constant K is equal to F over extension. Therefore, the unit of our slope or the unit of our evaluation is going to be what? Is going to be newtons per meters. So we are determining the spring constant K in what? In newtons per meters. So this is what I have for us. I believe this will contribute to what we have learned earlier